Chapter 1, Section 2, Estimation and Interpreting Graphs. Estimation is the process of finding an approximate answer to a math problem. So if you're estimating, you aren't trying to be exact, you're just kind of rounding to get close to what the answer might be. So since estimation uses rounding, we need to review the idea of place value. Rounding uses the concept of place value in order to know whether to round up or down. So the place value of a digit in a number tells the value of the digit in terms of ones, tens, hundreds, etc. I have a chart listed here above that has kind of a breakdown of your place values. It's not everything, it'll keep going to the left and the right, but hopefully you can see the pattern. What your place value does is it tells you the value of each digit. So let's say we're looking at the number 512, and I want to put this into my chart to figure out the place values. Well, one thing to know is when you have a number that does not have a decimal point, or you don't see the decimal point, what that means is there's an invisible decimal point on the far right. Just think of it in terms of money. If you have $10, that's the same as having $10.00. So that decimal point goes on the right. So the number 512, I know where my decimal point is now, so I can see where my number falls. Well, this means that I have 2 ones, 1 10, and 5 100s. So 5 100s plus 1 10 plus 2 ones. If I work out this math and I add it all together, I do get back that value of 512. One thing that I see students struggle with in regards to this chart and place value is we tend to think of the decimal point as like our turning point in the chart, and we want symmetry on both sides. But notice that doesn't happen, because if I'm looking just at the decimal point, when I look to the left, I go to the ones place, but when I go to the right, I go to the tenths place. And some students forget that there's not a once place. Notice the THS is at the end for all of your place values with your decimals, and you just have S's at the end of your place values for your whole numbers. So I always tell my students, rather than thinking of the decimal point as your turning point, think of the ones place and the decimal point as your turning point. Now you can kind of get that symmetry that you're hoping for. As you go to the right, you see the tenths, and when you go to the left, you see the tens. When you go out another place to the right, you see the hundredths, and another place to the left, you see the hundreds. So that might help you if you've ever struggled with messing up this chart a little bit with your numbers. Okay, so how do we use this chart to help us with rounding numbers? Well, to round a number, the first thing you need to do is you need to locate the place value digit of the number that is being rounded. For example, let's look back at that 512. And let's say we want to round to the nearest tens. Well, then I need to figure out which digit is in my tens place, which we know is the 1. Once you identify the location of the digit you're rounding, you always look to the right. If the digit to the right is 0 to 4, do not change your place value digit. But if your place value digit is 5 to 9, you want to add 1 to your place value digit. So let's just start with that step. So looking at our 512, I look at the number to the right and it's a 2. So that puts me in this category. So that tells me to not change my place value digit. So my 1 is going to stay the same. But what happens to the 2? Well, down below it says for whole numbers, that's what we're dealing with right now, all the digits to the right become zeros. So once I figure out my new place value digit, everything to the right of that becomes a 0. So that 2 becomes a 0. And this makes sense. If I asked you, what is $512 closer to? $510 or $520? Because those are going by tens. We would say that $512 is closer to $510. Or in other words, we rounded down. Now, if our number had a decimal point, so let's say we're looking at 17.38, and we want to round to the nearest tenths. Notice the THS at the end. I first need to identify my digit in the tenths place, which is my, and then like always, I look at the digit to the right. Now this time my digit's an 8, which is 5 to 9. So this tells me to add 1 to my place value digit. So I'm going to add 1 to my 3. But then what happens to my 8? Well, for decimals, all the digits to the right get dropped. So it just goes away. You could technically write a 0 there. It's not wrong, but it's not necessary. So when you have zeros at the end of your decimals, not within like your decimals, like if you have 0.102, you got to keep it. But if you have 0.400000, you don't need to keep any of those zeros. So we just drop it. So this would round to 17.4 if we were rounding to the nearest tenth. Let's take a look at problem 1. And I'm going to ask that you pause the video and try both of these problems on your own. I know one of them looks a little intimidating because of all the words, but I promise it is doable. So take a second, pause the video, and try these on your own. Okay, for part A, we are asked to round $147.38 to the nearest $10. Well, $10 is like a whole number, right? We're not talking about change. So this is really saying round 147.38 to the nearest 10. Our digit that's in the tens place is the 4. Next to the 4, I have a 7. That tells me to add 1. So I'm going to say this rounds to approximately $150. And you could kind of just think of this if someone asked you again, is $147.38 closer to $140 or $150? We would probably round up. Okay, in part B, on average, human hair grows a ½ inch per month. Assume there are 30 days in a month. How long does human hair grow each day? Round the answer to the nearest thousandth of an inch. Okay, so we know that we grow a ½ inch per month, so I'm going to write that as 0.5. And there are 30 days in a month, and I want to know per day. So to figure out how much I grow per day, I'm going to need to divide this by 30 so I can break that growth up into smaller segments day by day. So I need to divide 0.5 by 30. I'm going to do this by hand. So 30 doesn't go into 5, but it does go into 50. 30 doesn't go into 20, but it goes into 200 6 times. And it seems like that 6 is just going to repeat. So I'm going to have a bunch of 6s. I'm actually going to write out a few of them so we can talk about place values. Okay, so we're asked to round to the nearest thousandth. Remember, this is tenths, hundredths, thousandths. So I'm looking at that first 6. The number on the right is between 5 and 9, so that means I'm going to add 1. So this is roughly 0.017 inches per day. Let's take a look at a few different types of graphs. So starting with our graph here on the right labeled inventory, we see that we have these vertical bars. Each bar represents a category, and then on our y-axis, we just have some number. So I think that's just considering like the number of items in each category. This type of a graph is called a bar graph. Now, a bar graph is a graph used to compare amounts or percentages using either vertical or horizontal bars of various lengths. So again, we're comparing amounts or percentages using these bars. Now, the lengths of the bars correspond to the amounts or percentages, with longer bars representing larger amounts. So just quickly glancing at this graph, I can identify quickly that category 4 has the most in it, and category 2 has the least. Okay, our next graph we have here labeled sales. It's a circle, and we can see that this circle is broken up into different sections, and each section is labeled. This type of a graph is called a pie chart. Also sometimes called a circle graph, but it's constructed by drawing a circle and dividing it into parts called sectors, according to the size of the percentage of each portion in relation to the whole. So there's a difference between a bar graph and a pie chart in that a pie chart compares amounts based off the entirety or the whole. For example, let's say we did a survey in class about maybe favorite color, and you had 4 categories to pick from and you could only pick one. So the favorite colors, let's just use the colors in this chart. Let's say blue, brown, purple, and red. And then I go around and I ask everybody in the class what their favorite color is, and then I figure out what percentage of the class liked blue. 58%. 23% of the class liked red, 10% of the class liked purple, and 9% of the class liked brown. But I'm thinking of the entire class as the whole circle. All right, so we're comparing parts to the whole. Versus in our bar graph, we're just looking at individual amounts and comparing them to each other, but they don't all add up to one whole amount. That would be more like counting, let's say pets. So I'll do the same thing. Let's say I'm asking you guys the type of pet you have and I just count. So I go around the room and everybody raises their hand who has a cat. And there's 4 different cats. And then I ask who has a fish? And we have 2.5 fish. Again, doesn't make much sense, but let's just go with it. And then I ask, okay, who has a dog? And there's 3.5 dogs. And who has, I don't know, a turtle? And there's 4.5 turtles. But there may be somebody who has a turtle and a dog. So technically it's like I'm counting some students multiple times, but it doesn't matter because I'm just figuring out how many people have turtles, how many people have dogs, how many people have fish, how many people have cats. It's not in reference to the whole, and we can have some overlap. And lastly, we have this graph here with like a line going down and then going back up. It probably reminds you of things you've seen on TV or something when companies are showing sales going up and down throughout the year. Well, this is called a time series graph. Or oftentimes just a line graph. And what these do are they show how the value of some quantity changes over a specific time period. So again, this one is labeled profit. This could be showing how, let's say, a clothing company was losing money compared to 2003 up to 2004. They made less profit that year. But then after 2004, their profit steadily increased through 2006. So it just shows progress over time.